Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In this video, we are going to implement topological sorting. This video or the topological sorting is going to be in two parts. In first part, we will try to understand the topological sort, and we will try to create the basic structure that we need for our topological sort. And in second video, we will be implementing the topological sort. Now, what is topological sorting? So as we see this graphical representation of the data, so think of it like a game. So when you want to complete a game, you have to pass through multiple stages. Every stage has some dependencies. So you have to clear those dependencies, and the final order that it gets to for the end result or end stage is what the topological sort means. Now, as we see, if our end result is to do 4, so for 4 we need to finish 3, for 3 we need to complete 1 and 2, and similarly for 1 and 2 we need to complete 0. So now if I think of taking a left precedence, so the order would be 0, 1, 2, 3, 4, 5. So when something is on same level, we will be taking the left first and right second. So this is the first output of based on the left precedence. Similarly, you can have an alternate approach where we can have a right precedence. So in that case, the order would be 0, 2, 1, 3, 5, 4. Everything depends on which precedence you would like to take forward to. Now, so for our topological sorting, we need an adjacency list. Adjacency list would be the node and the prerequisites. So now we will be creating a map. So that map will have a key value pair. So the key for the map would be the dependency, and value would be a sequence of nodes which need to be completed as part of, or the when dependency is done we reach to those nodes. It is as simple as it is. So let's create these. So it is where we are creating, it is a map of adjacency list which will be created out of this list, and we will be using for left. So we will be using the first approach. For left, we will be creating a map where the first key is our int, second would be sequence of int. Now we need to implement the structure for our for left. MP is the map which is empty in the first iteration. L is the element of the list. Now we have to put together a logic. Now in first, when we start with the first element, our map is going to be empty, so we are going to append. Another condition would be if that element is not found or the key is not found, it should append the key. So we will build that logic. If not mp dot contains l dot underscore 2. Why it is not reading it? Okay, the reason why it is not reading it, we haven't passed a value here now. So it will give me an empty map. Now we are going to append to this. So what we are going to append is the value that is not found. So it will be very simple and very straight, and it will be now. So in first iteration, how we see is our L will be a pair of 1 comma 0. Now where L dot underscore 1 would be 1 and L dot underscore 2 would be 0. So it will check for 0 because the map is empty, there is nothing in there, and it will add this value. So now the map would look like 1 0, and it will have a sequence of 1. But what if the element exists? So we have to implement that as well. So in that case, we will collect all the values of the list into one of the temporary sequence and we will be appending it to it. So how it is going to be mp dot get. It is as simple as it is. We are getting the value here, and because it's, if you see, the data type is option, so we can use map and we can append. So beauty of map is if there is an error we can handle it very smoothly. So now we will just do get because we have some element in this, as we know. Now we have to insert this. So the question is that in this value, okay, this here it is giving us an error. It should be sequence of int. Perfect. So now we need to filter out. What we need to filter is we need to filter the key value first. It should not be present in there. Yes. So now the key has been eliminated and we are going to append a new key. The new key would be _2 and our temp list. Okay, now we have built a map of adjacency matrix. Let's verify whether it is creating correct map or not. Let's run this and we will have a result here. Alright, so we see that the dependency is here and the end or the target is here. So for 1 and 2 our dependency is 0, for 3 our dependency is 1, for 3 again our dependency is 2, and 4 and 5 our dependency is 3. So we have successfully created an adjacency list out of this input, which is as good as a graph. So we will see you in the next video where we will be implementing the topological sort. Thank you.